Welcome back. We're writing Little Band Computer in C++, and we're in the process of translating assembly language instructions into the relevant machine code. And we've got a few instructions in now, and we've moved to last time a lookup table structure for that's not what we're looking for. A lookup table structure here for our instructions, and now it should be relatively straightforward to tease out the translations of the remaining instructions. So hopefully we can race through that relatively quickly today and see where we get to. So if we find the tests, which will be hiding somewhere like this, and we're around about here, and we can continue in a similar vein as we have been doing with this kind of structure. The test is going to be whatever our next instruction in the queue is. So we've done add, we've done subtract. We might as well just continue straight on down the list to store. And then once we've been through all of this, it should be reasonably straightforward to start moving in the direction of multiple instructions. So a single instruction, a single store instruction and a halt is translated to 305. We'll just keep the number increments to avoid any clashes, though it shouldn't make any difference. And then we'll assert equal expected program, and then an expected program like so, which we've already indicated in the name of the test that we're after. Then we have a program where we do this, assemble the instructions, and we have an assembler, not quite, assembler like so, and we also have instructions like this, which we've missed something in here, which we'll come back to in a second, which is our label lookup, but that's fine. So we're having a store, which is sta, store in the accumulator, and we need an address. It doesn't really matter, but for some reason it feels like a good idea not to duplicate them between tests. That said, I'm starting to toy with the idea of seeing if we can remove some of the duplication of this test structure, which is quite similar. And by having some sort of predefined lookup of values, we might be able to avoid some things there. Well, we'll have a think about that after we've got this test through. But for now, let's continue and add our label, which we know is going to have a value of 5, like so. So, assuming I haven't typed anything in incorrectly, that should then fail in the expected manner, and we can hopefully trivially pass that by adding something to our lookup here. So in principle, just doing this, I think, unless I've missed something, should make our test pass, which would be very nice. let us examine. It is a very slow compiling process now. I wonder if that's because we're compiling with full optimizations on and things have got a little complicated with the way we're now doing tests. Excuse me. Shall we extract something for these tests? So in all cases for these tests, we have a set of instructions and an expected program. And if we can predefine a set of labels that we can use, then we could migrate this to having a slightly simpler structure. Do we want to do that? What might that look like? So what I'm thinking is, just to spec this out, is that we might want to do something like, oh hello, where am I putting this and what's the structure of the thing I'm putting it in? So this is in test fixture. We have a public run function, a private run function, and then we have a bunch of tests. So what I'm thinking, if we go, I think it's not a problem to put something in between here. What I'm thinking is we have something along the lines of assert instructions compile to program, and then we have a vector of instruction like so, called instructions, and a vector of int also like so, called program, and then we can essentially put together the non-duplicate parts of this, the duplicate parts of this, creating an assembler, creating a program from the instructions we've passed in, and asserting that the expected program, which I have got the name wrong there, is, which I'll fix in a second. An expected program like that. So this is taking out this formulation, and just for an example in here, what we can do is we can take out these things here, yeah, and we can say assert instruction compile to program. Yeah, there is a typo there, which we will fix in a second. And we have instructions and expected program. So that should be instructions, and so should that. Now the question is, does that work? I did. Indeed mean program. And if that works, then we can just shrink things down a little bit. Another typo. The compiler error messages these days seem quite good, even to the level of spotting where there's been a typo in the name of something. Do we like this? Do we like this? It's not bad, is it? I think that's a valid saving here. Let's trim out these items for the next couple. Does make things a little shorter in those cases. And then what we're going to need to do is we're going to need to set up some standard values for our lookup, which I think is okay. So if we were to do add label A is 1, let's just put does it matter if they're all the same? Let's at least do this, and we can cycle through them. And then we'll see what that looks like in here. So here we've got 102 and 103. So 102 would be B. And we can steal this. Let us see if that does the job. And if so, then we might as well just translate the rest. And it'll just make writing future tests just that little bit simpler. And it does. Excellent. So we can do the same here. That's 103, so that's a C. I can get rid of all that. And we can copy that. Let me... How does one do that? Does that work? It's my memory of keyboard layouts is letting me down, moving between PC and Mac, and only my fingers knowing where the commands for Vim are. So we'll do this the simple way for the time being, and just copy paste like so. But that's okay. I will refresh my memory later. So that wants to be D. We do not have, unfortunately, a 5, which I'm happy with. I think that would be getting a little bit overkill. So I'm happy to slightly change this test and not worry too much about it. And be fairly confident we're still testing something suitable. That should hopefully do the job. It does indeed. Excellent. And now let's just move quickly through the remaining instruction types. Didn't mean to do that. That'll do. Single load instruction is translated as, we can start just doing random numbers here now almost. It's LDA. Let us just check. It is indeed LDA. That's the one that's randomly 500 and something. So we're now going to have to change this as well. And that should hopefully fail in a suitable manner, and we can make that pass straightforwardly. It does indeed. That's excellent. So if we go here, we can do this 500 like so. That should pass. Thinking about it. Excellent. So that's load. We have 600s for branch. Like so. Single branch instruction translated as 602. That becomes a B. That becomes a bra. That becomes 602. That should fail. We're not really needing any refactoring in between each of these for the time being. I think it's all quite smooth. We will double check at the end of the sequence of tests here, just to make sure we haven't left anything on the table that we could clean up. But I think we're probably in pretty good shape. Excellent, that's that passed. One thing I have noticed is we have a hanging comma there, which we'll get rid of. And we have a branch. How's my guesswork? Is it 0 or is it positive? It's 0. That's going to be 703, like so. That's right, isn't it? BRZ, yeah, or BRZ if you're English, which I am. So I should be saying that. That should fail. At some point I might try compiling this with the optimizations off and see if there's any performance improvement. But for now I'll leave it. I think I can live with that. In general, BRZ, like so. And we're expecting that to pass, and then we should just be left with the branch if positive instruction that passes, and BRP, branch if positive. So we can copy this, branch if positive instruction. That's 804, why not? That should fail. It's thinking about it. It does indeed fail. We can make that pass nice and simply, like so. That should pass. And then we should just be left with the dat instruction, which is going to need to be handled slightly differently. Excellent, that passes. How does this look? Add label looks completely fine, and assemble for now also looks completely fine. There's still this little issue of the halt instruction that needs thinking about. I'm wondering if we put the if statement on this second part. If we swap the if statement over to say if the instruction count is greater than 1, then we'll do that. kind of like that idea. We get to a nicer setup here. So what we can then say is we can do this, which feels like the right thing to do. Slight change in the way we've structured things, but it does mean we get the halt in our lookup table as well. And we've not changed any of the behavior with respect to the tests. As far as I could tell, yes, everything still passes there. I think I like that a little bit better because this gives us a position of something sensible that we can start looping over when we construct more instructions. I'm also tempted, just for clarity, to extract this. I spell that right? Instruction value equals code value plus address value. I just feel that that's a little clearer for now, and maybe we'll end up inlining these two, perhaps. I don't know. It depends what we do on the error handling front later. I'm happy to leave these rather explicitly, as I think it reads a little bit more nicely. So that's okay. I'm happy with that for now. And the tests are all just that little bit shorter because we've extracted the boilerplate part of each test. So we are literally just creating a set of instructions and an expected program, and then calling our assert instructions compile to program, which is what we want. So just having a quick look in here, the last thing to do is the dat instruction. Ooh, this is interesting. We should be supporting the cob. That said, I doubt that's going to be used anywhere, is it? We technically should be in supporting that that variant of the naming as well. Let's just quickly slip that in. Actually, I'm going to do that at the top here, where we've got this, and we can just say a single halt instruction, a single coffee break. Is that what they're called? Coffee break instruction. Slightly odd naming, but that's fine. We should end up with that now. I think this should still fail sensibly, and should be relatively straightforward to make pass by adding another item to our lookup, which is what we want to do. Oh, that's intriguing. A single coffee break instruction is translated to a single 0. Why does that pass? Now that is a good question, isn't it? We've got an instruction. We are looking up, does this return? Interesting. Does code value return 0? Does the map return 0 if there is nothing that matches? I would expect something map C++. I would have expected maybe -1 as a more common key not found kind of response, but it's a little bit odd. So we've got this. K matches any of the elements. The container of the function returns a reference to its map value. If k does not match the key of any element, the container, the function inserts a new element with that key and returns a reference to its mapped value. Ah. So, have we... Ah, so it means you can do things like this. Which, to be fair, is quite a lot nicer than the add pair setup. However, it does mean we get unexpected results. So what's this? So is the at operator the one we're particularly after? Key value of the element whose mapped value is accessed. So keys have a reference to the mapped value of the element with the key. The mapped remote type. So what's going on here? No, that looks like it's doing exactly the same thing. So is it not possible? Is it not possible to do what I want to do? In fact, I don't know what I want to do here. I don't know what I want the answer to be if there's nothing in there. So the code works for now. Let's not overly worry ourselves about this. This is a sort of learning exercise. So I can refactor the code to be this. And the tests will still pass. But I've now at least got that extra test in there that will let me catch any errors that creep in later, which I'm happy about. But also, I can do this refactoring. Which, let's face it, looks considerably nicer. However, coming from other languages, that is slightly unintuitive. That would be the behavior. However, we are working in C++, and we should respect its idioms. So if that's the way it works, that's the way it works. I'm happy with that for now. And the rest is all good. So what I'm going to do is I'm going to commit that. Like so. So what's a good git commit assemble all remaining single instructions. I think that's fine for now. And next time we'll see what we want to do about the dat instruction.